Okay, so what's the strategy to test the second amplifier, actually both amplifiers? So yesterday I tested this amplifier and it seems to work about 12 dB of gain. Now the second amplifier, it's a bit tricky because it has an SPI interface. So I can show you, there is a connector here. Yeah, we have this connector which is talking to the SPI bus here. So you set the gain for this by sending a word to the SPI. So I'll just show you the datasheet. So the datasheet has, in the datasheet of this amplifier, there is a register, it's called register number 20, address 20. It's called the gain control. Sorry, not 20, 2. And by default, it contains 20. Now, there is a table. The first few bits, first one is reserved, second is for power down, by default 0 means active. And then there are 6 bits where you set the gain. Now, by default, it has this value, which is 20 in hex. So now there is a table here. So 20 in hex is this. So by default, actually, it has a gain of -6 or attenuation of -6. So by default, it doesn't amplify. It's actually attenuating. So in order to test this amplifier, we need to send the word. Now this is the values in hex that you need to send. This is the actual gain. So what I did, I made a script in Python. Right. So here is a script which is for Raspberry Pi Pico. So Raspberry Pi Pico is this tiny little board. So I'm programming the Raspberry Pi Pico and I'm giving the Raspberry Pi Pico here a value between, I don't know, what are the, from -6 to 26. Let's say I want to give it 18 dB, right? So if I go here in my script and I say 18 and I hit enter, it's going to send 08. So let's check the table. For 18, it's 08 in hex. So yeah, that works fine. So anyway, I made this script with ChatGPT. I didn't even bother. I couldn't be bothered to write it myself. But the thing is, doesn't matter how you write it. The thing is, I hooked a logic analyzer to see what is coming. So here I captured, so it's 02, that's the name, the address of the register, and 1A. So if I captured the data to see that the SPI actually works. So I don't want to hook everything and then realize nothing works. So at least I know now my Raspberry Pi Pico is going to send whatever I type in the terminal. So yeah, I made this so I can drive the amplifier. I can drive the gain of the amplifier. So yeah, I'll switch to the actual measurements with the scope. Okay guys, happy days. This is how the signal looks on the scope. This is a setup. You see here the Raspberry Pi Pico, which is communicating via SPI, the signal generator. Now I'm going to show you here in the terminal. I'm actually typing the gain here. So you need to believe me when I'll show you the scope. So I'll put here now, I'll put gain, I'll put 0 gain. So I'm just typing in the terminal, 0 gain, hit enter. So now it's not attenuating, it's not attenuating, not amplifying. So it's basically a pass-through. Now if I go -6 dB, so I'll go -6. This is attenuating now. Now I'll go 10 dB. Now 10 dB, 20 dB, 26 dB. So obviously working. So peak to peak here we have, what we have, 1.4 volts. So that's probably enough for my ADC. Now it's kind of wobbling because my connections are not great here. But yeah, I'm happy. This should go straight to the ADC. It's actually, it's getting close to the full scale of the ADC. So I'm happy to start the ADC and get back to the FPGA design, which is my area of expertise, let's call it. I hope you enjoyed, and I'll see you in the next one.